Hello everyone and welcome to my channel. Today I will be talking about a very basic concept in chemistry which you must have learned many a times, but you might not have understood the origin of this concept, and that is the concept of wave function. So how this wave function, from where this originates, and what is the importance of the wave function, that we will discuss in today's video. So this concept of wave function is a part of my Udemy course, Advanced Structure and Bonding in Chemistry, which you can go back to my Udemy profile and check this course out. And I will be discussing one of the lectures in that particular course that is about the wave function.
Hello friends, so in the last slide, since we discussed a little bit about the wave function, I thought that we should have some brief idea about the wave function or psi. So let's discuss that what's a wave function or a psi. So first of all, you should be able to understand from where this concept of wave function comes. So if you read some of quantum mechanics deals with the very microscopic particles, right? So in chemistry, under this we deal with the subatomic particles, especially the electrons. So the motion and behavior of these small particles, the electrons, are discussed in quantum mechanics. So if you recap your knowledge of quantum mechanics, then you will be able to recall that in quantum mechanics it has been described matter can have both the particle as well as the wave nature, right? So this is also matter, part of the matter, electrons. Particle and wave nature came from the de Broglie's equation, right? So I'm giving just a brief, so you may just go back and just have a look at what I'm talking about. So particle and wave nature was described by de Broglie, his initial experiments and all. Okay, so since it has particle and wave nature, matter, and since electrons, the subatomic particles, are also part of the matter, so these two should have wave as well as particle nature, right? So that is known as the wave particle duality of matter. Okay, now since they have wave and particle nature, but according to Heisenberg's uncertainty principle, you must have learned about Heisenberg's uncertainty principle, that is, it is impossible to determine both the position and momentum of a small particle like electron. So what does that mean? It means that if the wave nature is dominant, then particle nature will not be visible, and if particle nature is dominant, then wave nature will be diminished. So any one aspect. So in case of these small microscopic particles, we more often encounter the wave nature. And since electrons or the subatomic particles, microscopic particles, can be expressed as a wave, and a wave can be expressed as a wave function, right? So from here, this concept of wave function to describe the electrons or to describe the information where the electrons reside and what is their nature and how they orient themselves, all information about the electrons is described by the wave function, and it is a mathematical expression, right? So all these calculations regarding the electronic behavior and nature is given by the wave function, with the help of this wave function. And a very important development in quantum mechanics is the calculation of this wave function by Schrödinger. So Schrödinger's wave equation. That is why this is so famous, because Schrödinger calculated the value of this psi or the wave function for one electron system, that is starting with hydrogen. Later, for different other species with one electron, this value of psi was calculated, and later for other atoms the method of approximation was utilized, because we cannot calculate the exact value for multi-electron system. So approximation was applied. So that's about more about the quantum mechanics. So you should have a little bit a general, a rough idea that from where this psi value comes and why we are always referring to psi and psi calculations and psi and psi star and whatever it is, the energy levels and all orbitals. So from here the value of the concept of psi is developed from the wave nature of the subatomic particles or electrons. Okay, now since you know that psi is so important, so there can be several characteristics to the psi. So you can just have a look what are the different characteristics. So psi is a mathematical expression, right? And second is psi carries important information about the electron. What important information? Its energy, orientation in orbital, how it is oriented, its angular momentum, and all these described through the quantum numbers. You know that quantum numbers you have learned in atomic structure. Okay, next, what important things? Also psi can have positive or negative values, right? And this sign is required for mathematical calculations that we'll see when we describe the different bonding theories. And the psi with positive sign, so it refers to the wave functions which are in phase. If there is positive positive, then in phase. If there is positive and negative, that is out of phase. So waves are in phase and waves are out of phase. So that is the psi value. In phase leads to bonding and out of phase there is no bonding. So, and also it is described as the constructive interference, and it is the no bonding out of phase is destructive interference. And also one more important thing is that gives the probability density. Probability density means where there is a three-dimensional space, you know that, which we describe as orbital, where there is maximum probability of finding an electron. That means the electron density is maximum. So that is the mathematical expression of that space, or that value is given through psi square. So now you know that how important is psi mathematically, how we express it, and what is the significance. And from here on, when we describe different bonding theories, so you will encounter psi, the wave function, a number of times, and hope it will be easier for you to understand after this explanation.
I hope after this video you are quite comfortable with the concept of wave function, and this concept you will experience again and again as you come across various bonding theories and other aspects of chemistry. So I hope this lecture was helpful to you. And if you like my videos, please do like, share and subscribe. And please let me know what you want to learn next in chemistry in the comment section. Thank you so much.